Hi guys, Fabrizio here. We made those solar banks test machines, so that's to work more ergonomically at solar banks. So here, this machine here, we can drive it with this pair. So when we go down, then the solar tent will come down. We can also steer it with remote control. We have two remote control devices that is used. We are using Nico Easy Wave modules to steer the machine. So here, if we go down, then it goes fast until it passes the lower sensor, and then it moves slow. Same, we can go up. He's moving slow, and now he's moving fast until he reaches the top, and then he will stop. Okay, so there are 4 sensors. We have here the upper limit sensor, and then the sensor above is the protection sensor, that if he stops there, then he stops. Here we have also here, that's the lower position sensor. Here, if he comes here, then the machine will stop. That's a safety switch. You should not go past behind this. And this is a speed sensor. So this sensor will decide at which speed the machine will travel. Fast in the upper part and slow when the machine bends. So the inside, we have main fuse, some fuses. We have a frequency drive that's taking care of the speeds of the engine. We have 2 speeds, and then we have a Siemens logo. So here we have an engine with a brake. That's an engine with a brake. The brake signal is coming from the inverter, and that one is steering this contactor, and that will take off or switch on the brake on the machine. Because else, if there is some weight connected to the machine and it has no brake, then it can lower. So that to avoid that, we have a motor with a brake. For the rest, it's straightforward. Some fuses, safety switch, and some other simple, it's not so complicated point of view circuitry. Here at the front panel, we have the power on indicator, lamp test, reset button, alarm, and fast and slow selector. If you put him here on slow, then he will always move slow. And if you put him on auto, then he will move slow and fast. So that's the steering. So in the other cabinet, we tried to implement an overload protection. Normally you can do the overload protection via the frequency drive. You can set the maximum current, and if the engine current goes above that level, then he will switch off the engine. But the problem is that we have here we have 2 speeds of the engine, and you can only set 1 current. So it's very difficult to implement a correct overload mechanism when you have 2 speeds and 2 different currents. Therefore, we tried to add a current sensor. That's a Phoenix current sensor. I will add the link in the description. He has 3 wires, the power connection, 24 volt DC, and one 0 to 10 volt DC output. That's representative of the current. That's a 100 ampere current sensor, but we have only 3 ampere. So we passed the one phase of the engine, we passed it several times through the current sensor here. Then we have a bigger value to measure the current. So the current sensor is actually measuring the current of one phase of the engine. That 0 to 10 volt is going to the input of the logo, and when it's in logo, then we can play with it. Then we can say when the engine, depending on the movement of the engine, we can set some overload protections. The overload protection can occur, for example, when the bank is coming down and is blocked for some reason. Then we will get more current, and then we can switch off the machine, else we will break everything. So that's the difference about this one we tried it only and it works. Now we should implement it definitively. Okay guys, I thank you for watching and I'll see you next time.